This whole chapter is going to be dealing with solving quadratic functions, and we're going to look at different ways to do them. One of them is graphing, but first of all, we need to go ahead and learn how to graph quadratic functions first. So to graph a quadratic function, for the most part, we want to go ahead and find our x-coordinate of our vertex, which happens to be the same as the x-coordinate for your axis of symmetry. Any quadratic function can be written in the form of some number times x squared plus another number times your x to the first plus another number. When you're looking at what's in front of your squared, that's a. What you're looking at in front of your x to the first power, that's b. And then the normal number by itself is c. Your axis of symmetry is always x equals negative b over 2a, and the x-coordinate of your vertex is also negative b over 2a. So for this particular problem, if we were going to go ahead and try to graph this, first of all, I'd want to plug in b and a into negative b over 2a, or opposite of b over 2a. A in this case would be 1 because that's what's in front of your squared. B would be your 3, so it'd be the opposite of 3 over 2 times 1. In other words, the x-coordinate of your vertex is negative 3 over 2. So I'd want to then choose 3 numbers on each side of that. This is negative 1.5, so I'd want to try 3 numbers below negative 1.5 and 3 numbers above negative 1.5. And so the 3 numbers below negative 1.5 are negative 1, or negative 2, negative 3, and negative 4. The 3 numbers above negative 1.5 are negative 1, 0, and 1. Then I would go ahead and plug those into my calculator. I would go to the y equals, type in x squared plus 3x minus 1. Then I would go ahead, and by the way, for making your table, you could just take negative 4 and plug it in here by hand. But your calculator will do it just fine for you. So to plug it into your y equals, then you want to go second window. Second window gives you your table setting. You're going to want to go table start at negative 4. Make sure you use the negative button down by the decimal. Your delta table, the next line down, should be on 1. And the independent and dependent should both be on auto. Then to get your table, you want to go ahead and go second graph, which is your table feature. And then your table of values should come up. You don't have to do it that way. You can plug each number in by hand. It does not make a difference. Then all you have to do is just plot these points. 4 to the left, up 3. 3 to the left, down 1. 2 to the left, down 3, and so on. When you do that, you get this shape right here. Now, your axis of symmetry, if we write that out, is a vertical line that's going to be x equals negative 3 over 2. For your axis of symmetry, it's a vertical line. Make sure you write x equals. If you just put negative 3 over 2, you will not get it right. So for the most part, that's how we go about graphing. So consider this quadratic function. You're asked to find the y-intercept. Your y-intercept is where you cross your y-axis. Well, if I'm on the y-axis right here somewhere, I'm not left and right, so that means my x-coordinate is 0. So if I plug in 0 here for my x, I end up getting my y value to be 2. You may be asked to find the y-intercept, and that's how you would do it. To find your axis of symmetry, once again, you want to go negative b over 2a. Identify your a, your b, and your c. A is what's in front of your squared term. It's not always the first term if it's not in the proper order like this one here. And b is what's in front of your term to the first power. So you plug in opposite of b over 2 times a. So you get 4 over 2 on top. So your axis of symmetry is x equals 2. You cannot just put down 2. You have to go x equals. Now, the x-coordinate of your vertex is identical to what you got out of the negative b over 2a up here, which would be 2. So then you want to put 2 in the middle of your table, choose the first 3 numbers on each side of 2. So 3 numbers below, 3 numbers above. Then you want to go ahead and put this problem into your y equals. Then after you put it into your y equals, you'd want to go second window and start your table at -1. And then you want to look at your graph. Or you could go ahead and plug them in each by hand. Then you want to go ahead and plot your points. I'm assuming at this point you guys are pretty good at plotting points, so you would get a graph that looks like this. Now it's nice to know your axis of symmetry, because your axis of symmetry divides your parabola in half. If we were to draw in our axis of symmetry here, divide your parabola in half where each side is the mirror image of the other one. If you don't get the mirror image on each side of your axis of symmetry, that means you messed up in graphing it. So it's a nice way to check. Now, if a, what's in front of your squared term, is greater than 0, then your parabola opens up, and then your parabola would have a bottom point, because if it opens up, you have a bottom point, and then you would have a minimum. If your a value is negative, then you have a maximum, because if your a value is negative, like this here, then you open down, and you have a top point. The minimum here and the maximum here always occur at your vertex. If you're asked to find the max or minimum value, that's the y value of your vertex. However, if you're asked to figure out when your max or min occurs, that's the x coordinate of your vertex. So let's take a look at this one here. Let's graph this and find out when the max or min occurs and what the max or min is. Because a is negative, we know that we have a maximum, because if a is negative, it opens down and it would have a top point. So when your max or min occurs is the x coordinate of the vertex, which is negative b over 2a. So if we plug in negative b over 2a, we end up getting 1. That's when it occurs. Now, to find what that max or min is, all we have to do is take that x coordinate and plug it in to find the y coordinate. So take 1 and plug it in for each one of your x's here. And we get 4. So your maximum value is 4. It happens to occur when x is 1.